Dear children, today we will learn about electric field. We have completed electric force. Now come to electric field. So what is electric field? So electric field, that is the space around a charge in which its influence can be experienced. So you consider a charge Q. So what is electric field, or what is the electric field of this charge? That is the space around the charge in which its influence can be experienced. Suppose it is this space indicated by the circle is the electric field of this charge. That means if you place another charge, then you will find it exerts force upon this charge. If you place this charge at here, then what happens? Means outside this space, if you place this charge, then it will not exert force upon it. That means what is electric field? That the space around a charge in which its influence can be experienced by the presence of other charge. So if it is the electric field of this charge, if you place the another charge, that you can say it is as test charge at any place in this space, then you will find this charge can exert force upon the test charge Q0. So it is your electric field. If you place this charge, test charge outside this field, the source charge, it is called as source charge. What is source charge? Source charge means whose electric field is to be determined. Here Q is the source charge. Means here we want to find the electric field of this charge. So what is test charge? Test charge is the charge by presence of which we can determine the electric field of the source charge. Here by taking Q0 we can determine the electric field of this charge Q. So here Q0 is the test charge. So Q is the source charge and Q0 is the test charge. You know charge nature, two types of charge can exist. One is positive, another one is negative. So this source charge may be positive, may be negative, may be of any magnitude. But test charge, you always take test charge as positive and very small. So why you will take test charge is very small? Because if you take test charge is large, then it has more influence, so that the original electric field will be disturbed. So that we will take this test charge is very small and positive. Why it is positive? Why not negative? Because to know the direction, to fix the direction of electric field, we have to take test charge as positive. If you will take sometimes test charge positive, sometimes negative, then you cannot determine the direction of the electric field. To know the direction of the electric field, we have to take test charge as positive. So you remember, test charge is always positive and very small. So now come to quantitative definition of electric field or electric field intensity. So here you take a source charge Q. I want to find electric field at P. So what is the electric field or electric field intensity at P? I have to take a test charge Q0. We have to see what is the force acting upon this test charge Q0 due to the source charge Q. Let it be F. If F with the force acting upon test charge Q0 due to the source charge Q, then what will be electric field? Electric field or electrical intensity at any point is defined as the electric force experienced by a unit positive charge placed at that point. If here you will place Q0, if force acting upon it is F, then upon unit charge, what is the force acting upon it? So upon unit charge, that is the force will be F by Q0. It is called as electric field or electric field intensity. So electric field intensity, you remember, electric field intensity at any point in an electric field is defined as the electric force experienced by a unit positive charge placed at that point. So you know electric force or the electrostatic force, that is vector quantity. So here you see E vector is F by Q0, as electric force is vector quantity, so electric field is also a vector quantity. If it is vector quantity, then what is its direction? So from this expression you can say E vector as A vector by Q0. From your vector concept you can say electric field has the same direction as that of electric force. If the source charge is positive, you see, if the source charge is positive, and you know always this charge is positive, so this positive charge will repel the test charge. So as the force direction is this one, so electric field direction is also along the direction of the force, that is away from this positive charge. Similarly, if you take negative charge, and you know the test charge is always positive, the source charge will attract the test charge, because the force between two opposite charges is attractive. As it is the direction of electric force, so electric field will be directed along this, means towards the negative charge. So you remember, if the source charge is positive, the direction of the electric field, that is radially outward, means away. If the source charge is negative, the direction of the electric field is towards the charge, radially inward. So you get it is band, or you can say it is band rule, means positive away, negative towards. If source charge is positive, then the direction of the electric field is away from the charge, that is radially outward. If the source charge is negative, then the direction of the electric field is towards the charge, that is radially inward. So now come to unit and dimension. What will be SI unit? As you see, SI unit of the force is Newton and charge is Coulomb. So the SI unit is Newton per Coulomb. And dimension, simultaneously, what will be the dimension? Electric field dimension, you know, force dimension, force is your M1 L1 T minus 2 divided by charge is your A1 T1, that equal to M1 L1 T minus 3 A minus 1. It is your dimensional formula. The dimensions are 1, 1, minus 3 and minus 1.